Let's do an example of how to write the formula of a polyatomic ionic compound if you know its name. The way you're going to know that you have a polyatomic ionic compound is you're going to look at the name and you're going to look at the ending. So your polyatomic ionic compounds will always end in "ite," "ate," or you'll have hydroxide. So here I have an 8 and here I have an 8. So I know that I have a polyatomic ionic compound. So there are two ways to do this. You're going to choose whichever way makes the most sense to you. So the first way is by using valence electrons. So we're going to start with sodium. So if we look on our periodic table, sodium is element number 11. Sodium has 1 valence electron. Carbonate, our polyatomic ion, is on the back of our periodic table. It ends in 8. You find carbonate and you see that it has the chemical formula CO3 with a charge of -2. Now that -2 means that carbonate wants to take 2 electrons. It has 2 empty spots to fill. So my CO3 has 2 empty spots it needs to fill. If it has 2 empty spots to fill, that means it must have 6 valence electrons. So sodium, as a metal, is going to give up its valence electrons to CO3. So sodium transfers its valence electron. Well, the problem is my carbonate, CO3, still has 1 empty spot. We need to fill that empty spot. So how are we going to do that? Well, we need another sodium. If we have another sodium with 1 valence electron, sodium can transfer that valence electron to carbonate. Sodium has no leftover electrons, and carbonate has no remaining empty spots. So I'm done. I've transferred my valence electrons, and I can now write the formula. So I have 2 NAs and 1 CO3. So the formula for sodium carbonate is Na2CO3. Now there's another way to do this, and that's by looking at the charges on the ion. Either way, you will get the same answer. So if we start with sodium with 1 valence electron in the first column on the periodic table, sodium will always be a +1. Carbonate, we know from the back of our periodic table, is CO3 with a charge of -2. Remember, your positive and your negative charges have to cancel each other out when you're writing chemical formulas. So I have a +1 and a -2. +1 and a -2 do not cancel each other out, so I'm just going to start making a list, adding more positive and negative until they do cancel. So let's add another positive, Na. Now I have a total positive charge of +2 and a total negative charge of -2. So I have a +2 and a -2 which do cancel each other out. So I'm done. I can now write my formula, counting each of my ions. So I have 2 NAs and 1 CO3. As you can see, I get the exact same answer that I had before when I used the valence electrons. Again, use whatever method makes the most sense to you, and that could change depending on the problem.